another example to see if there's any association between growth rate and nutrient concentration. So this will be your X and this will be your Y. Okay, so let's just draw a graph first, an XY graph. So when you see a graph like this, what comes to your mind? So outlier can be defined mathematically as outside 2 times standard deviation. It can also be described visually. Okay, so from the graph itself, you can see clearly that this is an outlier. So if it's an outlier, what you have to do is you have to remove it. Okay. So if you were to remove it, then you will see the graph. Okay, so without the outliers like this, then if you add a trend line, you can see the relationship between the growth rate and the nitrate concentration. If you add a trend line here, what is obvious here is you can see that the R squared is very low as compared to this. So R squared correlation index, you can sometimes say like for example is 0.96. So if you write it in a sentence, you can say that 96% of the variation in growth rate can be explained by the nitrate concentration. Okay, so that's how you can write a sentence using correlation index. So 96% of the variation in growth rate can be explained by the nitrate concentration. Here, if you do not remove the outlier, it is only 3%. So 3% of the variation here can be explained, only 3% of the variation in growth rate can be explained by your nitric concentration. All because of this single outlier. Okay, you have to either you show your data like this, or you write it in your text. But you have to explain that this is present, but it is an outlier, and that your little analysis all do not consider this. Understand? Which means your final graph is still this, but you show people that you have this data here, but you do not consider it in your analysis because it is an outlier. So that is the proper way of doing it. Okay? Of course, it is easier to just remove it, so you don't have to explain so many things. But then it is, of course, unethical because once you start doing this, then you start doing other things also. So the best thing is don't start. Don't start removing data. Always explain your whatever data that you have, because especially in biology. Unlike chemistry and physics, where everything is more definite, biology, there's a lot of variability in our experimentation and results. Partly because biology is like that. Okay, it is not uh, as definite a science as physics and chemistry. So it is better to it is better it is of course acceptable to have variation or fluctuation in your data. Okay, so yeah, so that's what I want to point out in this question, the how you treat an outlier. Okay, so once you've done that, you can then do a normal linear regression. So once you have a normal linear regression, okay, so you'll have your slope, you have your intercept, you have your p. So p is less than 0.05. So that is a significant relationship. Okay. Here is also similar, where you do the okay. So sometimes you have graphs like this. So you're supposed to. So is temperature a important variable for growth rate? And then what is the Q10 for the growth rate? What's the Q10 value? Q10 value is uh, over 10 degrees Celsius difference. How many times did the growth rate increase? Okay, so you have sometimes you have data like this. How would you analyze data like this? From here you can see that it's relatively straight line here, but then it taper off here. Okay, so if you were to assume the whole graph, okay, it will be like this. But if you were to take only until here, so okay, so the results are very different. Your slope, okay, 0.0679 and 0.567. So if you were to calculate your Q10, Q10 is the difference in the growth rate over 10 degrees. So if you take from 10 to 20, what you need to do is you need to calculate it out. So if let's just say you're picking 10 degree and 20 degrees Celsius, so your y, which is your growth rate, if you use this equation, it will be 0.0679 times 10 plus the okay. Whereas for this, if you're using this equation, it will be 0.0567 times x is 0. Okay, so your Q10 will be your rate of growth rate at 20 over 10. Okay, because of this plateau, your Q10 results will be different depending on how you treat your data. So it's like what Eng says, when we plot the data, we have to plot the full graph. But how you analyze it, you can justify. Okay, justify because the plateau is here, so the linear relationship is only until here. Okay, you can justify that you only use this for further analysis, and that your Q10 is for this. Of course, when you say that, your Q10 is only valid for only from 5 degrees to 35 degrees Celsius. Okay, so you also have to set the range. So your relationship is valid from 5 degrees Celsius to 35 degrees Celsius. Okay, so that way, that is a better way of analyzing this kind of data. Okay, of course, you do not take the whole set, because obviously this is already plateau stage and no longer linear. Okay, so sometimes you get these graphs also when you're doing standard curves. Standard curves for when you're doing standard curves and you realize that it tapers off, there's a plateau at the higher end. So you should only take the linear portion. Okay, but should report everything, all the points here. Okay. Okay. Any questions? Uh, Usually, for if you're using a graphical software, so what you can actually do is you can just change this. Can you do that? Maybe you can't do it here, but if you're using an actual graphical software, what we usually do is we'll show all this data, then we will highlight these 2 points as outlier or plateau. Then we will just do the analysis for this part. Everything within one graph. We don't need to draw 2 graphs. Okay? But you just have to tell them that you are only using this part for the analysis and not everything. Okay. Any questions? Okay. So what about this one? Among temperature and pH, which is more important for growth rate? So you're trying to find association for these 2 variables, for these 2 variables, to see whether they affect the growth rate. So what you can do is you can do a not this graph. You can do a linear regression also. So your y will be your growth rate. For your x will be both temperature and pH. Then your output will be, we'll put it here. Okay. So this is called a multiple linear regression. Okay, because you are doing two variables here. So the regression equation is significant. Okay, but among the between temperature and pH, you can see from the p-value here that only temperature is important. It's highly significant, whereas pH is not significant. So between both temperature and pH, the growth rate is pH is more important. No, temperature is more important for growth rate. So if you were to do this in past, you're using a one dependent and independent. So you can see that the regression is significant. P is less than 0.0005. Okay. Then you can see that the growth rate against temperature this is against temperature. Okay, so you have variate is pH. No, pH and growth rate. I have to do something. Okay, so you can see basic how the columns that where you enter your data is different from what you observe in Excel. So for Excel, your Y is at the back, your two X's are in front. Okay, so you get to test your temperature and pH against your growth rate. But for pass, your Y is in front and the two X's at the back. So your dependent is here, your independents are here. Okay, one independent and two dependent. So your variates will be temperature and pH. So from here you can immediately see how the growth rate changes with pH, and changes with temperature. Okay, so from here it's clear that the temperature is a more important factor relative to pH. Okay, the P is less than 0.05, so the regression is significant, and this shows the number for temperature and pH against the growth rate. Okay. Uh, isn't it easier if you just do ANOVA? If you just do ANOVA, so it shows that there's differences among the 4 flowers that are sold. Okay, so when you do a turkey pairwise, you will see immediately that the hibiscus is sold less than all the 3 flowers. Okay, whereas carnation is sold less than roses and less than tulips, but there are no difference between roses and tulips. Okay, no significant difference between roses and tulips. So basically, when you have more than 2 columns of data, if you want to analyze it, you use ANOVA. Okay, so once you have ANOVA, then you can uh, if your ANOVA is significant, then you can do a turkeys pairwise to see which group is significantly different from each other.